Okay, this question talks about the altitude of a triangle increasing. You can see it, I've got a still one, but the triangle's moving, right? It's getting bigger and bigger and bigger, and the base is changing, and the area is changing. So the altitude of the triangle is increasing at a rate of 3 centimeters per minute, while the area of the triangle is increasing at a rate of 4.5 square centimeters per minute. At what rate is the base of the triangle changing when the altitude is 11 centimeters and the area is that? Okay. So, um, the first thing to do on a related rate problem is identify, I'll be a little more formal here. Identify the rate letters, variables. What rates are spoken of? Well, it says at what rate is the base changing? So I'll call it dB dt. That's what they're asking for. I'll call it base, the base, down here, the base of the triangle. Okay. And what other rate did I mention? The area is increasing at a rate of 4.5. So d area dt is positive. And positive because it's increasing. If things are getting bigger, their growth is positive. If it's shrinking, it's negative. So it's increasing. So they said decreasing be negative. Okay, identify the rate letters. So there we go. We've identified them. They are B and A. So then step two, write an equation with only these letters. So we need some kind of equation only involving A and B. And other numbers are fine, but no other letters. So what would that be? What's the equation that connects them? Well, the area of a triangle is 1/2 the base times the height. All right, 1/2 the base times the height. Now, there's a little bit of trickiness here. Oh, wait, wait. Oh, I missed one, didn't I? The altitude is increasing. Yeah. So I'm going to call that height. They called it altitude, but it's the same thing, right? You say, what's the altitude of that plane? What's his height? So they told me dH dt. I missed one. The is increasing at a rate of +3. It's also increasing. Okay, so I need a formula. I can use that in like B, A, and H. And here it is, the area of a triangle. This is the area of a triangle formula. 1/2 base times height. So, okay. So we're going to use that formula. And step three, um, d dt, both sides implicitly. So I'm going to take that area, but I'm going to scoot it over a little bit. Area is 1/2 base times height. And I'm going to go d dt and d dt. Because I want to know how is the area changing over time? It's going to obviously equal how the formula is changing over time because the area equals the formula. So let's do it. Take the derivative of both sides implicitly. So what do you get? Well, here you get dA dt. That's easy. Rate of change of area over time. The half is going to go to the front here. And then how do we take the derivative of this? Well, this is a product. This is two letters multiplied, huh? And so you know how that works. Here, I'll put the half in front of the whole thing. In fact, you know what? Actually, let me go back. Let's just do the half B. That'd be easier. The half B and the H. I'll just keep it easy. So the half B and the H. So do the half B first. So what's the derivative of the half B? Well, it's going to be a half dB dt, derivative implicitly, times H unchanged, plus a half B unchanged times dH dt. Let me pause for a second. You see what happened there? Remember when we do the product rule, they take turns. We did the derivative of that part there, and we did the derivative of that part there implicitly, right? In other words, we don't just take a half B and make it a half. It's a half dB dt times H plus, and then so basically take the derivative of the first part implicitly. The second part just sits there. Then the first part just sits there. It's not his turn. We take turns, right? times the derivative of the second part, 3h dt. Okay, so there we go. So now and then step 4 is plug in the numbers. We don't plug in the numbers till after the ddt of both sides. Why? Because you plug in constant numbers before you take the derivative of constant numbers is really just going to be 0. You're going to mess everything out. All right. So what does it say here? It says dA dt is 4.5. So this will be 4.5, and we add our half. I'll make it 0.5 just to make life easy. dB dt, do we know that? Wait, no, that's what we want to find out. dB dt, we're trying to find out. Okay. So I'll just leave that right here. dB dt is what we want to find out. H, do we know H? The altitude of a triangle is increasing at a rate of 3. Altitude is 11. So the height is 11 times 11 plus 0.5. What's the B? What's the base? The trend is increasing. I don't have that. I've got to get the base and how am I going to get the base? How do we find the base? Well, we know the formula again. Area is a half before we took the derivative. Half base times height. We know the area. It says it right here. The area is 92. Right? That instant in time, right when the area is 92. And it tells me the height is 11. Right at that instant. Right? The height is 11. The area is 92. I can actually find the base. I can solve for it. So 92, a half times 11, half of 11 is 5.5 B, okay? And then finish solving for B. Divide by 5.5. There's a little tricky side work we have to do here. So B equals 92 divided by 5.5. Let's go to Desmos. 92 divided by 5.5. 92 divided by 5.5. I'm getting, oh, that ugly number. Okay, I'm just going to leave it, 92 divided by 5.5, because it's not nice. So I'm just going to leave. I don't want to write something some weird decimal. That's B, okay? So I bring that back right here. It's 92 divided by 5.5 times dH dt, and that is 3, like that. Wow, this is no easy problem, is it? Look at all that. Okay, we plug all that in now. We got to solve this thing. How are we going to do it? Well, where's our variable? Right there. That's what we're trying to solve for, right? So let's bump this to the other side. So that'll become 4.5 take away the 0.5 times the 92 over. I'm just going to leave it all as is. I don't want a bunch of decimals equals. And then we've got the 0.5, the dB dt we're trying to solve for, and the 11. Right? So then just divide both sides by the 0.5 and the 11. Boom. And dB dt is alone. 0.5. So I'm just going to type all that into decimals. That way, notice how I don't like to mess with decimals. Just type it in. So 4.5 minus 0.55. So I'm going to go, okay. Okay, so I'm going to do the fraction thing. 4.5 minus, go back here. And we got, so 4.5 minus, oh, then we already did this part, didn't we? So I just need to take 0.5 times that answer times 3. 0.5 times answer times 3. 0.5 times answer times 3. 0.5 times answer times 3. See how I like to use the answer I just got? With Desmos' answer button, it's beautiful. Over 0.5 times 11. Over 0.5 times 11. Boom, there we go. I never had to mess around with decimals or anything. Negative 3.7438. Negative 3.7438. Negative 3.7438. negative 3.7438 is dB dt. Negative 3.7438. Look at that. So that was a tricky one. So let's run back over this. So step number one, identify the rate letters. Well, they mentioned dAdt, dHdt, and they asked for dBdt. Those are all three rate letters. Two of them we know, one of them we want to know. Write some kind of equation with only those three letters. Well, that's easy. Area is half times base times height. ddt, both sides implicitly. That can be a little tricky. DDT left side, right side's product rule. They take turns. First one goes, second one sits there. First one sits there, second one goes. And then we start plugging stuff in. Then we had a side trick. Over on the side, we're plugging everything in. When we got to B, we realized we didn't have B. Went over here to find B. We used the area formula, plugged in the area and the height, solved for B, and then brought that back and plugged it in for B, plugged everything else in, got dBdt alone like a variable. And there it is. That's a hard one. So there we go.